Hello, welcome back to Square Roots. Chapter 2, Learning the Concept of Square Roots. Now, square roots might be something you that kind of sound familiar because last time we learned about arithmetic square roots. But this is just square roots, so I wonder what's the difference between them. And then, of course, the next lesson we'll be learning about cube roots. Okay, the learning goals for today. Learn to perform operations including square roots. Is able to find the square root of a number. Okay, so let's get started with our introduction. So first, what is a square root? Well, a square root is if the square root of a positive number is equal to a, then this number is called the arithmetic square root of a expressed as this. And first, this is what we learned last time. This is the arithmetic square root. Second, I highlighted I underline positive number because I need to make sure that you understand that a is greater than equal to 0. Okay, so what are the operations we have learned? What are the inverse operations among them? This should be easy. So we have addition, subtraction, multiplication, division, and exponents. Exponents we learned last year in our grade 7 lessons, and we've been using them quite a lot now. So if you don't know about them, which I think you should if you're going to continue with these lessons, I'm going to put the link in the description down below. So addition and subtraction are inverse operations, so is multiplication and division. But what about exponents? Well, now that's where we get to the concept and properties of square roots. Fill in the blanks. So 3 squared is equal to 9. Then the arithmetic square root of 9 is blank. It's 3. First, it's given right in the problem. Second, this is what we learned last time, so I expect you this is a quick review. Okay, 2/5 squared equals 4 over 25. So then the arithmetic square root of 4 over 25 is 2/5. 3. The floor of the exhibition hall is square with an area of 49 meters square and the side length is 7 meters because something times something equals 49, that would be 7. So now let me ask you a question. Are there any other numbers that when you square them are equal to 9, 4 over 25, and 49? Now you might be really confused on what I mean, but remember, what's a new type of numbers that's introduced in middle school starting last year? Negative numbers. Does that give you a hint or ring a bell? Okay, so here's a quick exercise we're going to be doing together. We're going to be filling in the blanks. Okay, so 8 times 8 equals 64. Negative 8 times negative 8 equals 64 as well. Remember, when a negative number times negative number, it equals a positive number. Now, this is just a really weird expression right here, but I expect you to already understand that. Or I can also put the link down below as well if you need it. And you can quickly go back to review because it's something you need to be already knowing. Okay, 3 over 4 multiply that is 9 over 16, so it's negative 3 over 4. And it's the same pattern for all of this. It would be 11 and negative 11, 0.6 and negative 0.6. So if you're really good at calculating, you can already know that you could see, okay, so we know that there are 2 place values behind the decimal point in here, so then whatever that's supposed to multiply to it has to have 1/2 of that amount. So yep, that's right. But if you're not really confident in yourself, which is fine, what I would do would just be to convert this into a fraction, and then that would be easier. So then it would just be 0, of course, because 0 times 0 is equal to 0, and 0 is neither positive nor negative. And for negative 4 is none. So did you notice that? So why is negative 4 none? Why? Well, now that's when we come to the concept of the square root. Usually if so x is just a number, it's a variable, squared equals a, meaning x squared equals a, then x is the square root of a. So here's how we express it. This is how we express it. So there's this radical sign, and how this is different from the arithmetic square root is that they added this positive and negative sign over here. And it especially talked about how a is non-negative. So a here is called a radicand, and this over here is called the radical or root. Radical is just going to be the sign that's over here, but many people call it radical, so this is the phrase I want you to know. So how you read it would just be the square root of a. Notice the last time it was the arithmetic square root of a. Well, we just don't say the word arithmetic here. So no arithmetic, okay, because it's just square root of a. I want you to try something according to the concept just learned. So what is the square root of 144? Okay, well this problem, there is no the. What I mean is well, there's two answers to this. Two answers. One is positive 12, one is negative 12. So that's just how you would write that with only one symbol right here. Okay. What is the square root of 0? Now that's correct to use the, because 0 only has one answer to that, 0. Okay. What is the square root of 4 over 25? Okay. Well, there is no the, and that is positive negative 2/5. Does negative 4 have a square root? That was the case we just talked about earlier. Why or why not? Now here's the hard part. No, because a number squared cannot be a negative number. This is what we learned back in 7th grade when we were talking about calculations. So whenever you square a number, it just square. Whenever you square a number, you can't get a negative result. For example, 4, so what is going to be the opposite of negative 4? That would be 4. So negative and 4. Well, 4's square roots are negative 2 and 2, right? That's the square roots of 4. But negative 4 doesn't have any because negative 4 is negative. Well, later, maybe when you get to high school, you're going to start learning about imaginary numbers, but that's not something we cover in middle school here. So over here right now, all you need to know is that negative numbers do not have square roots. So through the answers to answer these questions, what can you find? So first question, how many square roots does a positive number have? What about 0? What about negative numbers? Now we just went over this. So positive numbers have like 4, they have 2. For 0, just 1, that's just 0. For negative numbers, there is 0. Well, unless you get to high school and you start learning about imaginary numbers, but I'm not going to get that complex right now. So, is the square of a number negative? So, since the square of any real number is non-negative, notice how it's real number, there is no square root for negative numbers, and there is no arithmetic square root either. So here's a summary for our key point. Here are the 3 main properties of square roots. 1. Positive numbers have 2 square roots, each of them as opposites. Opposites are, for example, pairs of opposites would be 3 and negative 3, 102 and negative 102. And 0 does not have opposite, by the way. 0 square root is still 0, because 0 is very, very special. It's neither positive or negative. And last, negative numbers have no square roots. So the conclusion I want you to have is that connections between square roots and arithmetic square roots. So here's a containment relationship. square roots contain arithmetic square roots. Arithmetic square root is a type of square roots. So when you say square roots, remember arithmetic square roots can only be positive or 0. But square roots can either, if it's a positive number, the square roots of that positive number can be positive and negative. So actually, arithmetic square roots is one of the square roots. The arithmetic square root is the positive one of the two square roots of a positive number. I hope you can understand what I'm talking about there. 2. Only non-negative numbers have square roots in arithmetic square roots. So what it's saying is that negative numbers don't have square roots or arithmetic square roots. And 3. The square root of 0 is 0, and the square root of the arithmetic. Oh, okay. This is the arithmetic square root. I'm sorry. Should I have put this up like this? Okay, probably order. So the arithmetic square root is also 0, because 0 only has one of each, and they equal each other. And here's some differences between arithmetic square roots and square roots. A positive number has 2 square roots, but only one arithmetic square root. And the notation is different. The square root is expressed as this way, with this negative and positive sign right in front of it. But the arithmetic square root expressed just with just radical a. And okay. So now we're going to look at some of the related operations. What are the differences between the two operations? So these are squares. But what operation is this? This is squaring. What operation is this? So here we're going to go to the definition of the square root. The operation to find the square root of number a, so a is just a number, is called roots or radicals, and a is called the radicand. What is the relationship between the square and square root? Squares and square roots are inverse operations. That's where it comes in. Exponents are inverse with radicals. Okay, that's how you spell it. So example 1. Find the square roots of the following numbers. And I want you to pause the video and do this by yourself. Okay, so the first one, we have negative and positive 8. Second one, it's a fraction. Well, we just see the top and bottom, the numerator and denominator. So it's actually positive negative 7 over 11. Not so hard so far. Now we have decimals. Usually kind of confusing. This is where students, when they try to do the calculations, they have troubles because they might just forget to count the number of place values behind the decimal point. So the square root of 0.004 is negative and positive 0.02. And you have to notice that in this number here, there are 4 decimal digits. And the last, number 4, it's positive negative 25. You might just come up with negative 25 over here, but you have to first simplify this. And then it's just 625. So then it would just be positive negative 25. Last one, the square root of 11 is positive negative 11. And when it comes to here, if it's not a perfect square, all you have to do is just use the radicand, okay? Not the radicand, the radical. The method conclusion. It is a common method to use the square operation to find the square root of a non-negative number. If the square root is a decimal, pay attention to the position of the decimal point. That's something I'm repeating over and over again throughout this lesson. You can also convert the decimal into a fraction first, and then find its square root. If it's a mixed number, first turn it into an improper fraction for easier calculation of this and this, where a is greater than or equal to 0. Think. Fill in the blanks according to the properties obtained below and explain the reasons of why you thought that. Okay? Well, over here, just 64. Same with here, 7.2. 49 over 121, and when it comes to 0, it's just 0. Now why? Because, look, remember how we talked about how exponents and radicals are inverse? Well, just like multiplication, division, and addition, subtraction, they cancel out. So then all you have to do is just look at the number on the inside, which is 64, and in this case. So can you express the resulting expression in variables? So what does that equal? Now, from the problem we just looked at, the conclusion is that the properties of the square root of the arithmetic square root of a is that a is greater or equal to 0. So usually this is equal to a itself with a greater or equal to 0. If it's smaller than 0, well, this won't work. Example 2, calculate by yourself. Okay. Alright, same thing. You don't even have to go and calculate this. You just look at the number in the middle because these two cancel out as inverse operations. So think, which basic property of power is used in this equation? So power of the product, the square of the product of a and b is equal to a squared times b squared. Power of product, very, very important. I am going to paste this link in the description below. It's something we learned back in 7th grade that I expect you to all know. There's this series of really important exponent laws and rules that later is, if you don't master it, everything will become super difficult for you. So I recommend going back to the description if you haven't mastered it yet, and we can move on. Think. Fill in the blanks according to the properties obtained below, above, and explain the reasons. Alright. This is just 2, 0.1, 2/3, and 0. Because these are inverse operations and you cross them out. So how can you use variables to express your expression? That's the conclusion. The properties of the radical of a squared. A is greater or equal to 0. Usually when the square root of a squared is equal to a, when it says usually. And it only works when a is greater or equal to 0. So when a is less than 0, what does this equal? Simplify. Alright, so for this, it's just gonna be 4. Okay, this is something that you can look at here. So this is interesting. Instead of actually memorizing this whole thing, this person who's trying to solve this was, well, I know that 16 is equal to 4 squared, so that I can write it as that and cross it out, which equals 4. So that's one way you could do it. Another way for the second one is you first simplify this, so it's 25, and then you just get 5. So is there any other solutions? Well, this is equal to also, right here, the square root of 5 squared, which is equal to 5 as well. So how can we simplify the square root of a squared? Well, the square root of a squared is equal to the absolute value of a when it's greater or equal to 0, or negative a when it's less than 0. That's what proves right here. So now let's judge. Please distinguish the right and wrong of the following answers. Alright? Okay. Let's look at this. So this is wrong because although there is negative 2 over here, you still have to, because if this is negative, remember back here, if this is negative, and a is less than 0, then just negative a. So this is wrong. The correct answer would be 2. The next one is wrong as well, because the square root of 2 would be Positive, yes, but then added to this negative sign would be negative. But any number squared has to be greater or equal to 0. So then this is wrong because there's a square here. Okay, this is correct because there was first the square, then multiply with a negative number, which makes this negative 2. Last one, this is correct as well for this is equal to 2, this part, but you have to times that with the negative sign, which gets negative 2. So discussions, what is the difference between this and this? Well, with the order of the expressions, of the operations, this is first square root, then power. This is first power, then square root. Range for a, well, in this case, a has to be greater or equal to the 0. Well, in this case, a can be any number. This table I want you to write down in your note because this is going to be very, very helpful when it comes to, tests with concepts and stuff. Now, when you simplify this, this is equal to a, while this is just equal to the absolute value of a. And I wanted to note that absolute value is always greater or equal to the 0. So it can never be negative absolute value. Square of the square root of a and the square root of a squared. And both of these equals a, while a is greater or equal to the 0. And performing some calculations. 2 skills I want you to master from today is learn to perform operations including square roots and is able to find the square root of a number.